Hello, class. Now, since we have been in the Learning Center for the past few weeks, and I am not sure when we are going to be moving back to a normal classroom, I decided, especially since the entirety of this unit we've been in the Learning Center, and as such I haven't been able to display any of these StatCrunch instructions for you. So in this video, I'm going to briefly state where to go for these various StatCrunch steps that you would need to take to obtain the answers again within StatCrunch. So back in section 6.1 of this unit, example number 3 that we did in class dealt with creating a probability histogram, and I gave this associated table with that, which I already pasted into StatCrunch for our purposes. We would, in this case, to graph this, since unfortunately we're not going to be able to create a nice histogram of it, we're going to go to graph, go to where it says bar plot here, and we don't have data since we just have this frequency chart. It's going to be with summary. The categories in are going to be our x values, which is the variable 1 in my table here, or the x column in this table. And then the probabilities on the right here are going to be our counts, which in the table in StatCrunch is variable 2. Now again, we could change whatever we want with it if we wanted to. I'm not going to in this case. Just hit compute, and you'll be given that graph. And again, since it wants it as a histogram, those bars are supposed to be touching, but my example unfortunately is not doing that. Now, example number 4 wanted to compute the mean of a discrete random variable, and example number 6 wanted the standard deviation. And both of those had the same chart, which actually, let me just copy and paste from Excel very quickly on here. But the way to do that, which I tried to describe nicely in class, but again, without visualization, not too much I could do about that. But once you have that data inside of StatCrunch, in order to get the mean and standard deviation, we are going to go to Stat Calculators. And for this one, we want to go all the way down to Custom. Click on that. The values in would be at the x value of the table I just pasted. And the weights would be the p of x, the probabilities that we just pasted. And then hit compute. This will give us our associated, kind of like a histogram, kind of, only just without the bars. But this, though, gives us a mean and standard deviation. So that's where we got the 2.39 for the mean from example 4 here. So I'll just type down here right now. 2.39 for the mean, and the standard deviation was, according to this, 0.706 I want to. That's where we got those values from class. Example number 7 gave a separate chart, wanted the probability distribution and then the mean. Now, as I said in class, as I'm going to paste this data in here, as I said in class, you could either do the math outside of StatCrunch and then just type it, which is one way you could do it. Or if you really want to get StatCrunch involved in it, I'll quickly go over that. Now, I did note the instructions on how to do that here in the question, where we take each of those frequency values, divide it by the sum of all those frequency values, or in this case, the sample size. Inside of StatCrunch, in order for us to do that, we're going to go to data as we have previously. Go all the way down to where it says compute, and then expression. Now this calculation we are going to take each of the values in the frequency column, so frequency, and divide it by the sum of all the values in that frequency column. Again, so we get that relative frequency, and also known as that discrete probability distribution. So that'll be dividing by the sum of frequency. And then hit compute. When we do this, we'll be given those frequencies, and then again, you'll just round them to whatever the test, for example, is going to want you to round it to. And then for the mean and standard deviation of this, we would then go to Stat, Calculators, and Custom again. The values now are going to just be the X column, but the weights will now be the frequency, the relative frequency that we just calculated, this new column, and then hit compute. Doing that will give it this. Again, as a graph, the mean, as discussed in class, was about 5.76, and the standard deviation was about 0.608, rounded to 3 decimal points for that one. That's for that one. And then finally, question number 8. So unfortunately, on 2 pages, so let me actually make that all on 1 page. This one wants the given probability histogram was actually that one that we did not need StatCrunch for, so I'm not going to restate that one for that. But that was section 6.1, the associated parts inside of StatCrunch. And again, we were not calculating actual probabilities of anything involving this, and as such, we were not touching this bottom probability statement. Now, for section 6.2, which let me just shorten this so I could use StatCrunch at the same time. For section 6.2, this was again one of these ones that kind of required StatCrunch a lot, and we did not have that projector working. And this one required absolutely 0 data. Okay. So first, for example number 2. Now, I wrote these formulas out in class, which again, formula not bad for, exact values, like exactly 5 in this example number 2. But when we start needing to go through lots of values, like the at least 3 or the 5 and 7 inclusive, it can get daunting. So instead of StatCrunch for this, we're going to Stat, Calculators. This was that binomial distribution. We're going to binomial. Okay? And it will give us this particular graph. Now, this first one, we had a probability of success of 41%. So that will go in for this p-value here, 0.41 as a decimal. And we have a random sample of 20. So 20 will go in for n. And we want exactly 5 a wireless only. We're going to change this inequality symbol to be an equal, and leave it at 5 here. Computing that probability gives us that value, as we said in class, of 0.0656. For the at least 3, now the way that we would compute that was 1 minus... Well, actually, we don't need to do that, actually, specifically. For the at least 3, that would be when it's greater than or equal to 3. That we could just compute here instead. Whoops. 3. We could just compute that instead StatCrunch. For at least 3, that value, which, as we did during class, 0.9972. For the between 5 and 7 inclusive, and again, I tried to describe this during class, you go to where it says between here on the top left. Click that, and then use 5 and 7 instead of this probability statement. So 5 goes here, 7 here. that value is 0.3381. That was for that example number 2 that we did. For example number 3, I have 65% of adult Americans favor the death penalty, sample of 15. We want no more than 6 favoring. So we're changing this sample size here to be 15 from the problem. The 65%, or 0.65, will be that success rate. And we want no more than 6. So let me change this back. No more than 6, so less than or equal to 6. Throwing that into StatCrunch, we will get a value for this cumulative probability of 0.0422. Example number 4 is kind of a continuation of that one that we did before. Again, 41% wireless only. We have a simple random sample of 300 households. We want that mean and standard deviation for that. That one was just that calculation that we did during class, which unfortunately is not going to show up inside of StatCrunch here. This was, for the mean, it was 300 times 0.41, which made a value of 123. The standard deviation, on the other hand, takes then the square root of, let me write this out, square root of that value that we just got, so 300 times that 0.41 times the probability of failure, which in this case is 1 minus 0.41, or 0.59. That calculation made a value of, let me just get that calculation back actually. So we're taking the square root of 300 times 0.41 times 0.59. They gave us a value of about 8.52. Rounded to 2 decimal points. The question about, is that result unusual from that 300 households, 143 were wireless only? That was that one using the empirical rule. So in this case, they wanted you to check. Yes, they wanted you to check using the empirical rule if 143 then is, well, in this case, it would have to be greater since 143 is greater than 123. You will need to check if it's greater than 123 plus 2 times 8.52. Again, since for unusual values, that needs to be greater than 2 times the mean plus 2 times the standard deviation. And that, on that note, that value was 140.04. 143 is indeed greater than that. Right? So because 143 is greater than 140.04, then yes, it is unusual. Now for number 6 here, the 35% of parents spank their children. They have 150 adults, finds that 65 spank their children. They want to know how much of the 150 parents surveyed would be expected to spank their children. Again, that was using that the expected value which would be 150 times then the 0.55. So doing that will give us a value of 82.5 as the expected value. And then finally, for the 90% of flights are on time, suppose 13 are randomly selected. We want exactly 11 being on time. So we have a sample size of 13. Probability of success is 90%. And we want exactly, so equal to 11. Gave us a value of 0.2448, which we interpreted in class to be out of 100 flights, exactly, well, about 24 flights are on time. And that one was for section 6.2. Then finally, for one of the sections that we were just doing, section 7.2, this was the one with the normal distribution, and as such had a different set of instructions for that. But I already typed out these probability statements on here, so we could just follow along with that. With the first example that we did during class from section 7.2, we had a value, a mean of 40.21, standard deviation of 3.78, and we want the proportion of height less than 40 inches. So we are going to, for this calculator now, go to Stat, Calculators, and then go all the way down to Normal. That will bring us to this screen, and we will type in the mean of 40.21, standard deviation of 3.78, and we want where this probability statement is less than 40. Now, do note, as I said in class, there's only the or equal to portion of this does not change the answer, and the only other option we have is the greater than or equal to. The fact there's an or equal to has zero impact on the result. But quick and compute to that gives us our probability of 0.4778. Now, but between 43 and 48, again using this between button, we could put 43 here and 48. That probability was 0.2106. Likewise, example number 2 uses a mean of 38.72, standard deviation of 3.17, and we want the 30th percentile. So let me change this mean to 38.72, standard deviation to 3.17, and we want the height of a 3-year-old female at the 30th percentile. This would be a less than, and this would be 0.3. At the 30th percentile, that's going to have a height of 37.06 that one's about to. Now, for example number 3, that was the one we had to do those 2 calculations and got those 2 SAT scores. So this one had a mean of 516, standard deviation of 116, and we want the scores that separate the middle 90% from the bottom and top 5%. Again, there's more than one way to think of this, but I'm not going to bore you with those details. For the top 5%, we will have the probability be greater than or equal to 0.05, which, for the top 5%, we want this probability equal to, not that value, 0.05 to go here. That top value is about 707. For the bottom 5%, we're going to change this to a less than or equal to, and this back to 0.05. That will give us the bottom value of 325 about. Now, for the value of z sub 0.10, so that alpha being 0.10, to calculate that uses the mean and standard deviation of z-scores. So the mean of z-scores is always 0, and the standard deviation is always 1. And since this is the value of the area to the right of that z-score, this will be a greater than or equal to, and we will use 0.10 on the right. That value is going to be 1.28. Now, for example number 5, because the normal curve is symmetrical, we only have to do this calculation once. So once the area under the normal curve to the left of -2 and to the right of 2, and then added that together. So we only have to do this once to get that value. So if we do the probability of that being greater than or equal to 2, we get ourselves a probability of 0.0228. And since it's symmetric, the other one's going to be the same exact value of 0.0228. If you need some convincing, if we change this to less than or equal to and this to a -2, we get the same exact answer. Adding those two probabilities together gives us a value of 0.0456. And then finally, for example number 6, this uses a mean of 275 and a standard deviation of 16. And we want this to have a less than 235. So less than 235. That will give us a probability of 0.0062, which, as we said during class, is indeed less than 5%. So yes, a very preterm baby is indeed considered unusual for this case. So those are those StatCrunch usage for these different problems. Again, we did not have the projected to do it inside class, so hence why I'm going over with that. And again, the test for this particular unit will be coming up very shortly. And as such, I want you to see in action how to do those different results. Let me know if you have any questions or concerns about it. Thank you.